Okay, now I'm going to start with the physics. Which chapter do I start with? So okay, I'm going to start with chapter 17, then 18, then 37. Why is it not entering? Where's the test bank? Where's the test bank? Where's the test bank? I don't know what chapter it's waves to. So okay, so this is waves, and therefore let's go on to number 1. The speed of a sound wave is determined by what? The transmitting medium. Like in air is not the same as in water. That's the speed of a sound wave. So number 2, the transmitting medium. Number 2, take the speed of sound to be 340 meters per second. A thunderclap is heard about 3 seconds after the lightning is seen. The source of both lightning and sound is what? Is about 1,000 meters away. I don't know where did they get that. A sound wave has a wavelength of 3 meters. The distance from a compression center to the adjacent refraction center is what? Is B, 1,5. You divide that by 2. A fire whistle emits a tone of 170 Hz. Take the speed of sound in air to be 340 meters per second. The wavelength of this sound is about C, 2.0, Young-Thug 2.0. So during this time interval of exactly 1 period of vibration of a tuning fork, the emitting sound travels a distance of 1 wavelength in air. 1 wavelength in air. The answer is E. So at points in a sound wave where the gas is maximally compressed, the pressure is a maximum. Maximum compression, it means that maximum pressure. So you are agree to decrease the volume to its maximum, therefore increase the pressure to its maximum. So you are listening to an A note playing on a violin string. Let the subscript S refer to the violin string and A refer to the air. Then A, Fs is equals to Fa, and lambda S is not equals to lambda A. So beats in sound refer to a combination of sound waves of slightly different frequencies. The sound waves generally frequency different. To produce beats, it's necessary to use 2 waves of slightly different frequencies. Okay. That question it was repeating. This question are the same. In order for two sound waves to produce audible beats, it is essential that the 2 waves have slightly different frequencies. Mostly the 3 questions are the same. So the largest number of beats per second will be heard from which pair of tuning fork? So 763 and 774 Hertz. So 2 stationary tuning fork, 350 and 352, are struck simultaneous. The resulting sound is observed to a beat with a frequency of 2 beats per second. So when listening to tuning fork of frequency 256 and 260 Hz, one hears the following number of beats per second. So 6, 4. You say 260 minus 256, it gives you 4. Two identical tuning forks, they vibrate at 256 Hz. One of them is then loaded with a drop of wax, after which 6 beats per second ahead. The period of the loaded tuning fork is what is C, 0,004. I don't know where do they get that, but to get to 300 we need 4. To get to 260 we need 4. 0,004. Which of the following properties of a sound wave determine its pitch? Frequency determines the pitch. Two notes are in octave apart. The ratio of the frequencies is D, which is 2. So 17. Consider two imaginary spherical surfaces with a different radii, each centered on a point sound source emitting spherical waves. So the power transmitted across the larger sphere is the same as the power transmitted across the smaller, and the intensity of a point on the larger sphere is less than the intensity at a point on the small. So the sound intensity 5,0 meters from a point source is 0,50 watts per meter square. The power output of the source is B, which is 160 watts. The standard reference sound level is about the threshold of human hearing at 1000 Hz. At 1000 Hz, the threshold of human hearing at 1000 Hz. So the intensity of sound wave A is 100 times that of the sound wave B. Relative to wave B, the sound level of wave A is D, plus 20 decibels, positive 20. The intensity of certain sound waves is 6 microwatts per centimeter squared. If its intensity is raised by 10 decibels, the new intensity is A60. Multiply that by 10. It gives you 60. And then if the sound level is increased by 10 decibels, the intensity increases by a factor of C of 10. The sound level at a point P is 14 decibels below the sound level at a point 1,0 meters from a point source. The distance from the source to point P is It's 5,0 meters. So to raise the pitch of a certain piano string, the piano tuner it tightens the string. The piano wire has length L and mass M. If its fundamental frequency is F, its tension is E, 4 liter meter F squared. Liter 4 liter F squared. If the length of the piano wire is increased by 5%, what approximate change in tension is necessary to keep its fundamental frequency unchanged? So the answer is C, increased by 5%. Mostly they gave me the answers. A piano wire has a length of 81 centimeter and a mass of 5,0 grams. So if its fundamental frequency is to be 394 Hz, its tension must be 63 newtons. So a stretched wire of length 1 is clamped at both ends. It is plugged at its center as shown. The three longest wavelengths in the wire are C, 2, 0,67, and then 0,4. 2, 0,67, and then 0,4. Like we have two 29, we have two identical strings. We have A and B have nearly the same tension. So when they both vibrate in their fundamental resonant notes, there's a beat frequency of 3 Hz. So when string B is tightened slightly to increase the tension, the beat frequency becomes 6 Hz. This means that before and after tightening, B has a higher frequency than A. So number 30, I feel like I've got questions. 60. Itago number 30. Number 30. Two pipes are open at one end and closed at the other end. So pipe A has a length L and pipe B has a length 2L. Which harmonic of pipe B matches in frequency the fundamental of pipe A? So it's E. There are none. It's neither third, neither fourth, neither second, neither the fundamental. There are none is the answer. Which column? A column of argon is open at one end and closed at the other. The shortest length of such a column that will resonate with 200 Hz tuning fork is 42.5 centimeter. The speed of sound in argon is what is C, 340 meters per second. Tuning fork, it is almost like a denote. A tuning fork produces sound waves of wavelength lambda in air. This sound is used to cause resonance in a column closed at one end and open at the other. The length of this column cannot be 2 pi over 4. Cannot be 2 pi over 4 or 1 over 2. Okay, this is the first part.